In this tutorial, we'll be creating this seamless animation loop with a Blender Python script. Hey, I'm Victor Stepanoff. I'll be guiding you through this Blender Python tutorial. Today we're going to be creating this seamless animation loop. To create this animation loop, we'll be working with a subdivided mesh, applying a displace modifier to the mesh, animating this displacement modifier, and then finally we'll create a cool material to make this look great. Let's get started. To start working on the main part of the script, we're going to be using some helper code to get us to that point. I've provided a link in the description under helper code. Open that link in your favorite browser, click on raw, select the code and copy it. Open Blender and navigate to the scripting workspace right here, hit new, and then paste in the code that you just copied. Go ahead and run this code. And this code clears the scene for us, sets up a couple of area lights, a camera, then this emissive ring in the middle. I'll hit Z on my keyboard and then hit rendered. You can see that the ring is emissive. I'm going to go back to solid. I'm going to hit control space and you can see that we have an empty right here. This is going to be the empty that controls the depth of field of the camera. We're going to be using that. And then we have a empty that the camera is tracking. So basically this is the helper code that's going to be executed each time we run the script, so we don't have to worry about it. There are some other helper functions that we'll be using during this tutorial. I'll be showing you those helper functions as we need them. And also at the very end of this tutorial, I'll show you how you can get this helper code for yourself without needing to copy it around into your other scripts. Let's get going. The very first thing that we need to do is we need to add a mesh, and the mesh that we'll be working with is a round cube. I'll create a new function right here and call it create mesh. And the very first thing that I'm going to do is I'm going to use a helper function that adds a subdivided round cube into the scene. Let's go up here and find it. So right here we're using, there's a function in the helper functions called add subdivided round cube. It has a parameter of a radius. It adds the round cube, which is found in the extra meshes add-on that comes built into Blender. So we have to enable it. There's another helper function to do that. And then it adds this operator right here that will add the round cube. And not only that, we're going to add this round cube and we want to apply a subdivision modifier, and we'll return both the reference to the round cube and the reference to the modifier itself. Just copy this right here and go back into the main script. I'm going to go right here and provide an argument, and I'll get the reference to the round cube and the subdivision modifier right here. Let's go ahead and call this function in the centerpiece, in the create centerpiece function. And let's go ahead and execute this script. And this is the round cube. So what's special about a round cube is it looks like a sphere, right? And then it has this nice topology, and this really will allow us to make this displace modifier work really well. So that's that. And I want to also right away modify some parameters on the subdivisions of this round cube. So I'm going to go into modifiers and I'm going to set the levels in the viewport to 5, and during the render I'll set the subdivisions to 7. And we're going to get some code right here in the info panel. So I'll go ahead and copy this right here. I'm going to paste that in. Also, I want to shade smooth, so I'll right click on the mesh itself, click shade smooth. That also is going to give us a command in the info panel down below, and I'll paste that command into our new function as well. And instead of using this right here, we can use the reference that we got from our function that adds the subdivisions and the round cube. So I'll just replace that like so. Let's go ahead and run our script. And you can see that in the modifiers tab right here, you can see that now this is automatically set for us. All right. And actually, let me update this. I'm gonna set radius like so. Next, I want to add a control empty that will parent our round cube to that control empty, and then animate that control empty to bob up and down, so it'll add a bit of detail to our animation. Let's go ahead and add this control empty right here. I have another helper function that will allow us to do so. Control empty, and we'll pass this control empty into the create mesh function by provide it as an argument, and we're going to parent this round cube to this empty. So it's the round cube, do this control empty. Okay, that looks right. Let's go ahead and run our script. And I'm using this run button right here, but you can also use Alt-P to control the running of this execution of this script. And that will be a lot faster. I'm just doing this so you can see that when I'm running the script. Let's go ahead and find that control empty. I think that's it right here. So round cube, control empty, and let's go into wireframe. And this is the control empty now. See, it's our round cube is parented to this empty. All right, and now let's animate this control empty to bob up and down. And I also have another helper function that will allow us to do so. And let's go ahead and find that helper function, and here it is. So animate bob, animate up and down bob, and it's gonna just use a start value, a mid value, and then we're gonna provide an object, which is gonna be our round cube. In this case, we're gonna set the loop length, and then we also will need to get the start frame. It's running out of space here. And I'm going to be setting the start frame at a random frame between 0 and 60. And I'll show you how that's going to work. And the thing is that we're going to be creating a data loop. So this is going to take our object. It's going to loop whatever is in our location. It's going to set the start value, the mid value, the start frame, the loop length, right? And after all that's done, we're going to apply a cycles modifier to the F-curves. I'll show you what that means in just a second. So let's go and, you know what, I'll comment this out for just a minute, and I'll just copy this. I want to show you what this actually does, so it'll be a lot easier to show you than to explain that. So let's update this. Okay, this is how our function call is going to look like. We're going to provide the control empty as the object, the target object. We're going to set the start frame, or sorry, the start value of the location of the empty and the mid value. So it's going to go between 0.5 and minus 0.05, and it's going to go up and down for us. Okay, let's go ahead and run our script, and let's select our timeline so we can see the timeline here. And let's go ahead and select our empty. So you can see that we've added these keyframes, and you can see our control empty is going up and down, but you can see it only does it once. And let's go and check out the animation graph editor, normalize. Okay, so we have the graph open, and we're going to take a look at the actions on the Z, and then go into modifiers, and then hit cycles right here, and look at that. We have this cycle going on automatically, right? And it will be actually seamless, so you won't even see the difference. So let's go ahead and take a closer look. I'm going to hit space to continue the animation. And you can see that it is seamless, right? So I'm just pressing at the very end of our loop, and it just continues to go. And that's all possible with the cycles modifier, right? And this is exactly what we're going to be doing with that piece of code. Let's go back. I'll collapse. Well, actually, you know what? So if I run this again, right? And I'm going to select the control empty that has this animation applied to it, right? It only has it once. And then let's go back and uncomment that piece of code. So this was add F curve cycles. So the code for that is right here. We're getting the object and then we're looping through all the F curves, applying the modifier, the cycles modifier, and then we select the repeat before and after parameters. So it's going to be a looping before and after. So let's go ahead and run our script. Again, select our control empty and look at that. We have this nice animation applied, and now we have this slight detail in our animation where our control empty is going up and down. All right, I'm going to go ahead and collapse that. And let's solid. Next, we need to apply the displace modifier to our mesh. And actually, we're looking at the code right here. Let me show you what this code is doing by hand so you'll understand better. I'm going to go into this property panel with modifiers right here. And selecting our mesh. And I'm going into modifiers. I'm going to modifiers, and then I'm going to use the displace modifier. We're going to create a new texture by hitting this new. And then we're going to go into the properties of that texture. And we're going to select the Voronoi texture. And we're going to set the size to 0.75. And then we're going to set the brightness to 0.4. And if you look at our mesh right here, it already has something interesting going on. But that's not all. We also want to add an empty that's going to be controlling this texture so we can animate it. So let's go ahead and use this helper function in our code. I'm going to select this. So let's just quickly look at this. Creating the new texture, right? We're adding the displace modifier. We're applying the texture that we created. We're naming it. We're using the coordinates, the object coordinates. Then we will create the empty itself, and we will apply, we're gonna use the empty as the thing that controls the texture, and we're gonna return both the displacement, the texture, and the empty. Let's go ahead and use this code in our function. So down below, you're gonna scroll down in the create centerpiece function. I'll add the code right here, like so. So again, I'm using this function. I'm returning the displace modifier texture empty, and I'm naming it just base noise, and I'm using the texture type of Voronoi. You can look up the other texture types in the documentation, how they are named. So this is not just a random string I thought up. I'm using something that Blender understands. Then I'm setting the noise scale, the noise intensity, and the intensity of the texture itself. And this looks good to me. And let's go ahead and just comment this out. I'm going to use Control / to comment it out. Just running this script to make sure that, hey, this without this code, nothing really happens. Oops. And I'm just going to uncomment this by hitting Control / again. So uncommenting that, running the code, and look at that. Now we have our displace modifier applied to our mesh. Okay, and let's go ahead and find that. I think that is the control, so the empty base noise. So we've selected that, and if I start moving it, I'm going to hit G on the keyboard, and I'm going to start moving that, and you can see how the texture is modifying. So the displace modifier is updating the texture, and look at that. All right, I'm going to replace that and let that go. Now we want to animate our displace modifier, and before we do that, let me just move this code into a separate function. Call it animate displace modifier, like so. And then I'm gonna call this here. And to loop this displace modifier, we're going to be making the empty follow a path, and in particular, it's going to be a circle. So it will loop seamlessly as we animate this this displacement modifier. And I learned this trick from Midge in one of his tutorials. I'll link the video in the description. So we first need to add the circle curve. And I'm using one of the helper functions that's defined above. It just adds a circle curve. So the same thing as the Shift A and then circle and then curve right here. And it has a radius of 0.2. We're assigning the reference to that curve into a new variable. Now we need to make this empty active. So this way we can apply a constraint to this empty. I'm also going to set a random rotation to this empty, like so. So each time, let's actually run the script right now to see what this current code does. Let's double check that we can call this. So it's called here. We're creating the displacement modifier with a texture empty, creating the circle curve. We're not using that just yet. We're just activating the empty so we can apply the constraint just in a minute, and setting the random rotation that's going to provide a random rotation on the X, Y, and Z. So each time we run the script, it's going to slightly modify our texture that's applied to the displace modifier. So each time I run the script, so I'm just clicking and running the script, and you can see that we have different starting shapes of our mesh. All right, now we want to add this constraint. And to do that, let me do this by hand by selecting the empty that controls the noise. So this is empty, and we're going to add a new constraint, and then we're going to add the follow path. We're going to select the correct circle. Actually, you know what? I didn't name it properly. Let me quickly fix that. So I'm going to set the name of this so we can clearly see that this is what we want. And let's go ahead and rerun our script. And now let's select our noise. So let's apply that constraint again. So follow path and then select that circle. And let's go ahead and copy that code. So it's adding the constraint right here. So this is the info panel and then setting the target. I'm going to paste that. So, and we're using context empty objects. This is the same thing as that. So follow path, the target. And the target will be, it's using this BPY data objects and then that path. Actually, we don't need to because we have, we've defined a reference to our target already. So we don't need to use that thing that we copied from the info panel. And one thing that we do right now, so if we just just run this code, and the thing is that, yes, it's this circle. Let's go into wireframe. You can see that there is a circle curve and this empty is applied or is following this path. So if I use this offset right here, you can see how this is modifying our mesh, right? And actually, let me get into solid mode and I'm gonna play around with this offset more so you can see how we're just going around in circles. But if I hit space and I'm going to make this animation go, the empty is not getting animated around this circle. So let's go into wireframe. You can see it's just staying in place. And to fix that, I actually need to press this animate path like so. And let's copy that code. And now with that code, let's rerun our script and then hit play. And you can see that this empty right here, it's now going around our circle mesh, or not our circle curve, sorry. So, but you just notice how it jumped, right? This is because we didn't set the duration of the path correctly. Because the duration of the path, if we look if we select our curve, and then we go into the curve properties and then go into path animation, you can see that the duration or the number of frames that it takes for any object to go around the whole path is 100 frames, and this is not true, right? For us, our animation length is 360 frames, and this is only 100 frames, right? And we need to fix this, and we need to set this to whatever frame length of our animation, and we have that parameter actually defined in the context. So let's first update this parameter. So I'm going to set this to like 360 or something. Right? I'm going to go into the info panel right here, copy that code, go under right after we created the circle curve right here. So we're using that reference, setting the path duration to 360. This is just hard coded, meaning that if we change the duration of our animation, this is not going to be updated. This is not good. I want to actually set this from the context. So I'm going to update this in just a second. So we're passing in the context. And so centerpiece gets the context from, this is the centerpiece call context. We need to find the scene setup. And in the scene setup, if we go scroll up, in the scene setup, we have the code that sets actually how long our loop is. So we're using 30 frames per second. Our loop is going to be 12 seconds, and we're calculating the frame count. And we need to get this frame count and set it to that duration of the path, of the animation path for this circle curve. And it's really great that we created a context here and we're setting the frame count so we can use it right away. And we can use it right here. So we're using the context. The context is a dictionary, and we're using that frame count and setting the path duration to what we want. So let me go ahead and set this to like 100, back to 100. So this is incorrect. And now let's rerun our script. And now we're going to select our circle curve, and you can see this now is set correctly, and this will loop perfectly. So you can see that this empty is following along, and watch as it gets to the end, it's going to loop perfectly right here. And look at that, right? Seamless, just what we wanted. Okay, let's set this to solid, play it again, and you can see that we already have something interesting going on here. All right. And if you're learning something new and enjoying this tutorial, make sure to hit the like button. I'll greatly appreciate it. Okay, now that we have our base mesh done and the displace modifier animated, it's time to apply a material to finish things up. And if you've never worked with Blender materials, this next part might be a bit challenging because I won't be going over the basics of this. If you've never worked with Blender materials, I can highly recommend tutorials from Ducky 3D, CG Matter, and Curtis Holt. I've learned a ton from those channels, and I would highly recommend them if you haven't created any Blender materials before. That said, I'll try my best to break down the things that are happening, and let's get into it. And the very first thing that we're going to do is we're going to create the material itself. And I'm going to go up here and create a function right away that's going to contain our code for our material. And here is the code, and I've added a documentation string here. I'm creating a new material, naming it glass plus metallic Voronoi. I'm using the nodes, so we're going to be using nodes for this material, and I'm right away removing all the nodes from the material, so I don't want any default nodes. I just want to create all the nodes on my own, and then I'll return the material itself. So let's go ahead and call this in our main centerpiece function. I'm going to call it here, and next, since we created the material, now we need to apply the material to our object, and to do that I have a special helper function called apply material, and that's it. Let's go ahead and hit Z and then material preview, and you can see there is no material currently applied to our mesh, and that's going to change as soon as I run our script. Let me run that, and oops, and this should be placed in another spot. So see, it's using the object data materials, and the currently active object isn't actually what we want. Is actually an empty, and we just need to move our code, either provide a parameter to this function to allow us to pass in any object, or we have to put it right after we create the mesh. So that was my mistake. Let's cut this, And let's create the mesh. So right after creating the mesh, we're going to apply the material to that mesh. So, okay, this should work. Now that worked without an issue, because now this is the last active object before we apply the material. Let's go into the shading workspace, and we've selected this mesh, and you can see all the nodes are deleted. Nothing is here, and we're going to fix that right now. Go back to the scripting workspace, and let's go ahead and start adding the shader nodes. And the very first node I want to add is the principal BSDF node. That's going to be representing our metallic part of our material. And actually, I'm going to go ahead and create a new function up here that's going to set all the parameters we need to create that metallic material. And here is that function. So we're passing in the material into this function. We need that to get access to the node tree, and then say we need new nodes. We need a new node that's going to be the principal BSDF node. And to get the correct type name, I usually look into the Blender Python documentation, and I look up the node that I want to add. We are getting the reference to that node that we created. We're going to set the metallic and the roughness of that shader node. And I'm also going to collapse it, so hide it. You'll see what that means in just a second. I will go ahead and call this right here. And this is going to be, and let's execute this code. And again, nothing really changed. Let me select that shader node, and you can see now we have a single node right here. And this is it, and you saw that it was collapsed, so that is what the hide part of that code is doing. And we're setting the metallic and the roughness. Let's go back and actually plug this in to an output node that we need to create as well. And let's pass this back in. And here's the code for creating the output material node. This is the node that we're going to be plugging in our BSDF node, so we can actually have something on the surface. And I'm also changing the location of the node because everything gets added into the center of the node tree, and I want to move this node so it's not right on top of the BSDF node that we just added right here. Let's go ahead and run this code. Go into shading, click on that mesh, and you can see that we have the principal BSDF and the material output. Now we need to connect the principal BSDF to the surface right here, and we'll do that just below right here. And here's the code. We're using the node tree, and we're adding new links. So we're going to add a link between the principal BSDF node, in particular the output, the BSDF output, and we're going to use the material output and then use the surface input, right? Let's go ahead and execute that code. And straight away, after I executed the script, we have the metallic material applied. Let's go into shading, click on the mesh, and look at that. Now we have these two nodes connected. All right, now let's create the glass part of our material. We're going to create another principal BSDF node that's going to have the properties that we need for glass material. And we're going to go up here and define a new function that's going to contain the code that defines this new principal BSDF shader. And here's the code. I'm calling it create glass node tree. I'm passing in a color palette. We're gonna look at that in just a second. The material and the location on the Y. We're getting a random color from a color palette, and that's just gonna go into a base color variable right here. Again, we're creating the principal BSD of the same thing that we used in the metallic node, right? Same thing. We're setting the parameters of the base color to the thing that we just got, the random color. We're setting the metallic, specular, roughness, transmission, emission strength, and we're hiding it, and we're updating the location. Since they're going to be around about the same location where the metallic node is, I just want to move it a bit below that. And then we're returning that principal BSDF node. Let's go ahead and call this down below. Let's go ahead and call it after that. So that's going to be the glass node. I'm going to set the location on the Y to -300. And we need to pass in the color palette. And we're going to do that from the context. So where we're creating the material, I want to use the context. And right here in the main function, I'm selecting a random color palette. And I'm using that, so create materials, and this is a dictionary, right? I'm looking at the color palette that we've selected right here. Let's go ahead and take a look at what this select random color palette is. In the helper function section, I'm going to scroll up, and here we go. You can see that we're selecting a random color palette. We're loading the color palette, so these are the color palettes I've selected, and we're going to select one of these, and this is then going to be used later on to get the random color. So we're going to use color palette that we selected here and choose a random color from it. And we're going to have to translate this Xcode color into something that Blender understands. And I have a special other helper function that does the conversion. I've created a whole tutorial on this particular function, so if you're interested, go ahead and check that out. And let's actually return to our code now. So this is where that color palette is coming from. We're selecting a random color and applying it to that base color. All right, I think this should work, and we're not making the link to the output node just yet. Let's go ahead and run that. Look into the shading workspace, and now we have two principal BSDF nodes, and you can see that this one is set. It has the transmission, right, the emission. It doesn't have any metallic, specular, and so on, right? Okay, let's go back and write some code that's going to connect all this. And the node that will allow us to mix these two principal BSDF nodes is called the mix shader node. And we're going to place it in between the output shader node and these two principal BSDF nodes. We're going to define it right here. And here is the code for that node. Again, we're adding the mix shader. I've looked up the type, and we have the reference to it, and updating the location. And this thing right here is starting to become a chore. I need to update these locations each time. I actually want to create a separate variable that's going to help me organize where these nodes are going to be located, and I'll define it right here. I'm going to be using two variables. One is the step and the other one is the current location. And since we are going to be having these two principal BSDF nodes on the same X, so at the very start, I'm going to go ahead and update the X location right after those nodes are added. And I'm going to use that current location, and I'm going to bump that location once more right after we add the mix node. And I'm going to add this right here. All right, let's go ahead and run that script. Let's go into shading, look that up, and you can see we haven't deleted that connection just yet, but now we have the mix shader, these two principal BSDFs, and the output right here. And now we need to connect this principal BSDF into one of these shader sockets, and this other principal BSDF into another shader socket, and then connect this like so. Okay, let's do that. And we'll need 3 links. So I'm going to go ahead and create 3 more links right here. I'm just copying that. I'm going to copy the glass right here, and then the mix shader right here. So these are going to be the from node, so from which node we're going to be connecting, and I'm going to be connecting the principal BSDF and the glass shader node into the mix shader like so, and I'm going to be connecting the shader output to the surface of the material. But let's go ahead and run the script. If only I could spell. So it's shader and shader. Okay, now that's set. Let's go ahead and look into the shading workspace, and you can see that there's clearly an issue with this. We did connect these two shaders into the principal BSDF, but there's a slight issue here because the input node is both of the input nodes are called shader, and that is an issue that we can solve by taking a look at these inputs. And to see what's going on, I'm going to print out the name and the identifier of the input sockets. And I'm looping over the inputs, and each one of these is the socket, and I'm printing the socket name and the socket identifier. Let's go ahead and run this code, and I'm going to open the toggle system console, and this button will be only available on Windows. On Mac and Linux, you'll need to do some setup to see this system console. Unfortunately, I have a video for each one of those operating systems. Go ahead and check that out. And here it is. Let me make that bigger. And as you can see that, so these are the outputs that we got. So the FAC, the shader, and the identifier, right? So for both of these inputs, both of the shader inputs, they're named the same, so I can't really reference them as I usually do for other nodes. But I can use the identifier to reference this socket, and that's what I'm going to do. I'm going to create a lookup table using the identifier to reference the socket that I want. And here's the code for the lookup table. And I'm using a dictionary comprehension. This is a slightly fancier way of writing a simple for loop like you see right now on your screen. It's exactly the same code, but just in one line. And I'm just looping over the values of each socket, so it's similar like this. And then I'm just using the identifier as the key and using the socket as the value, actually the reference to the socket. It's not the name, right? It's literally the socket itself. So I can use the identifier down here and get the correct socket. So let's do just that. So instead of using the mixed shader inputs, I'm going to use the lookup. And the very first shader, I don't really need to do much because the shader is named, the input shader socket is named the same way. But for the second one, remember that one was called underscore 001. So it's shader underscore 001. And with this code, now we should be able to connect the two principal BSDF nodes to the mixed shader node. Let's go ahead and run the code. Let's go into the shading, click on that, and look at that. We have these two principal BSDF nodes connected like so. And notice now we can use this fact to kind of switch between the metallic and the glass principal BSDF node, and we're going to be controlling that and modifying that in just a minute. Go and do that. And before I do that, let's clear this up so I don't need this anymore. To allow us to isolate the center of our mesh and the Voronoi displacements, we're going to be using a special spherical mask. And I'll define this above right here. And here's the code. It might look a bit dense, but don't worry, it's pretty straightforward. I'm naming it create spherical gradient texture mask. I'm providing the material, the location, the step on the X and the Y location. I'm adding a texture coordinate node, a mapping node, a texture gradient, a color ramp, and I'm connecting all these nodes and returning the color ramp and the location that we calculated after adding all these nodes. And I'm updating the gradient type to spherical in the texture gradient. And I'm also updating the color ramp right here, the position and the interpolation. And that is pretty much it. let's go ahead and move this into the metallic node tree. I'm actually gonna have to provide this. I'll set this to 300. Let's not forget to set that right here. So that's the step we're passing in right here. And instead of using making this a super long line, I've split it up. So I have this tuple, the return, and I'm just unpacking it in the next line right here. This is actually two values, right? And I'm unpacking it here, and I'm renaming this basically into another variable and using that to update the location, since now we have all those nodes in front of this principal BSDF. I want to make sure that they're all aligned, and let's also update this X node location like so. And now we need to return this color ramp node and this location. And now let's update this return. Oh, and actually, you know what? I don't want to do this here. I want to pass in, make sure that the two BSDF nodes are actually aligned. Glass. So, okay, let's go ahead and run the script and see how that looks. Okay, there's an error. Oops, I deleted this parenthesis. Now that works. Okay, let's see what we have here. So we have that old setup right here that we were just looking a minute ago with the principal BSDF and the mix shader. Now we have the texture coordinate mapping, this gradient texture with the spherical parameter used and the color ramp, right? And now we're going to be connecting this color to this FAC. And you can see right away, so I haven't connected this just yet, but you already see the result that we have the glass and the metallic setup right here. And let's do that final connection. And let's put that link right here, like so. We have the mix shader color ramp node. We're getting that color, and then we're connecting to that back right here. And let's go here and just disconnect that. So I want to make sure that we're doing this by code, and look at that. I'm looking into the 3D viewport and we already have that connected. All right. And now I want to create the edge highlight that you saw in the animation. And this is what I'm going to be highlighting right here. And let's go ahead and define a new function that's going to do that. And here's the code. Again, I'm just trying to speed things up because there's a lot of code here. Let me explain what's going on. So we have this great pointiness edge highlight node tree, and we're again passing the color palette, material, the location on the X, the step on the X, and the location on the Y. We're adding the geometry node that will allow us to access the pointiness of the mesh, and this is going to be only working in the Cycles rendering engine, and so make sure that we're using that. The code actually sets that for you, but it won't really work in Eevee. We're adding another color ramp. We're connecting that pointiness and the color ramp right here, linking that together. We're adding a mix node, and we're creating the same thing that we did for the mix shader node, where we need to create a lookup table, remember, with the identifier and the socket for the input and output. And then we're setting the type, the data type that we're going to be using is the RGB, where the blend type is going to be mix, setting the location. And this is some interesting code right here. I want to make sure that the highlight color of the edge and whatever is the rest of the metallic mesh are going to be two different colors, because since we're getting a random color, there's a good probability that you can get the same color twice, and this would basically will make it so there is no highlight. And I want to guard against that by having this while loop. So I'm going to try 5 times to update this color. So if both color A and color B are the same, I'm going to get another color, another random color, and then I'm going to subtract from the try count. And I'm also making sure that we're not, in an infinite loop. For some reason, maybe there's a palette that contains the same colors, right? And we're just going to loop infinitely here. So this is just a guard against that. And since we have the lookup table, we're going to apply to the A color and the B color the colors that we got here. And then we're going to connect the color ramp and the mix RGB node. And finally, we're going to return the resulting color and the node location that we calculated during this function. Do this and move it into the metallic like so. I'm going to set location to -100. I'm going to again return the 3 values that we're returning as a result, and then unpack it on the next line. And sorry, not the 3, but the 2 results. And I also want to get the maximum, either the spherical or the edge highlight. So what I'm doing here is I want to make sure that depending on how many nodes we add here or here, I want to make sure that we get the maximum location on the X, so everything's nicely aligned. And before we return from this metallic function, I want to get that pointiness, that this RGB mix node output color, and connect that to the base color of the principal BSDF node right here, like so. So I'm using this output right here, and then connecting to the base color of this principal BSDF node. All right, let's go ahead and run the script. And there's an error, and the issue is I haven't passed in the color palette. So let's do that. So it needs to be one of the parameters of the create metallic tree node and palette, and we're calling that create metallic node tree right here. Okay, now let's go ahead and run that. And to see the edge highlight, we actually need to go into rendered mode. And you can see that there is an edge highlight. Let's go ahead and render that. And you can see that there is an edge highlight going on just as we wanted. All right. And let me actually show you the resulting nodes. So here they are. So it's the geometry node. We're getting that pointiness connecting to the fact we have that color ramp. We're mixing this RGB mix node with the colors. We're using these 2 colors to apply to the pointiness and the primary metallic part of our mesh. And all that is going into the base color of the metallic principal BSDF shader node. All right. I know this is a lot, but for the final touch, I want to add a layer weight to the glass to get that slight detail that it's going to look super, super cool. So let's go and update the glass node tree right here. And here's the layer weight node. We're just adding it and updating the location. And now we need to add a color ramp and plug this layer weight into that. Like so. So we have the color ramp. We are updating the colors for both of the elements. We're updating the position as well, and then the location of the node itself in the node tree. And then plugging in the facing output of the layer weight into the color ramp back input socket. And now we need to plug in the resulting color ramp output into the principal BSDF node, and in particular in the emission socket. So we have the color ramp, the color, and the principal BSDF that we're adding here, and using the emission input socket. And I learned this recently from a Ducky 3D short. It's it's a really cool effect. Let's take a look at how that looks. Yeah, and the problem is that I need to pass in the location step. I did not do that just yet, so let's do that. The glass node after the material, I want to pass in that step, the node step, and that should work. Let's do that. All right, a closer look, and I need to update this. It doesn't look good. And let me just set this to 600. How that looks. And actually, maybe just a bit lower. Like 600. All right. Okay, look at that. So we're adding the layer weights, the color ramp, and then passing in the resulting color into the emission, and that is going into our mix shader, right? Mixing with our metallic principled BSDF. And let's go ahead and render the result. And look at that. Okay, that was pretty intense. And if you're feeling that this is way over your head, don't worry. This is pretty complicated stuff. I would think that if you don't have any experience with the shader nodes, this is really hard to understand. So don't worry, and just treat this code as some helper code. You don't have to really deeply understand it, right? I'll provide a link to the full code in the description, so don't worry about that. Now, we have a lot of helper code, and let's take a look at how you can get all that helper code without having to copy it around. And if we go and look at the helper code, I'm just going to go ahead and, like, from here to the very top, so all of this helper code, right, that's converting stuff, that's deleting the scene, setting up different parameters, like making objects active, tracking the empty, and so on. Like, all this code is actually, I'm going to go ahead and comment all that. So this is not working anymore, right? If I just run the script, it's going to give me an error, like it's what's missing. Let's see, 700. So yeah, the first thing that it runs into is the missing time seed, and this is a really cool thing that allows us to pin down a particular random value, right? And you can just paste in that random value right here, and the next time you run the script, it's going to generate the same exact scene, right? So all of that is actually a separate module that I've created. It's called bpybb building blocks, and you can get it for yourself as an add-on or install it through pip. I have a separate video that explains how you can install it for yourself, but all that code right here can be replaced with the following imports. And here are the imports. So all that functionality is hidden behind all these few lines. I don't think we don't need add-on utils, and I don't think we need time import as well. And let's see if that works. Oh yeah, and I need to enable this for myself. So I'm going to go into preferences. I already have this add-on installed, so it's bpy building blocks, and there's going to be a particular version depending on when you're watching this. I'm going to enable that, and now look at that. We can run that code. All of that code is still working. Let me delete all this commented code just to show you how much we are saving. Right, so now we have a lot less code to deal with. Of course, there's still some code here, but it's a lot less than it was before, right? Let me just continue to just hit that run button, and look at that. All that functionality just hidden behind all these import statements. And for the final thing, I want to share some things that you can change in the script to customize it and make some different and get some different results. And the very first thing that comes to mind is heading on over to your favorite website where you have palettes, color palettes that you like, and just replacing these color palettes with some of your favorite color palettes. This is probably the easiest thing to change. So if you do one thing with this script is just go ahead and update these color palettes and see what you get. Next, we have of course, the different settings for camera. So you can place the camera in a different location, right? Play around with the depth of field. Also, you can play around with the lights, right? And maybe use something else, not this emissive ring. Just think about how you can update this script in a different way, and maybe adding an HDRI to the scene and making look, maybe adding a backdrop. And whenever you're generating something in particular and you really liked it, so this time seed function right here, as soon as it generates a seed based on the current time that you're running, it's gonna copy that seed into your clipboard, right? I already mentioned this, and you can just put it here. So let me see the rendering. So this is the current rendering scene, right? I'm gonna go ahead and run it, and look at that. Nothing is changing because I pinned down the seed. And let's set this to 0, and as soon as I set this to 0, right, this will evaluate to false, and we're gonna generate a new seed like so, right? Some other things that come to mind is, so yeah, this is the light setup right here. We have the discs and we have the emissive curve, right, that we're extruding. So we're extruding it to make it a bit like thicker. The thing that really comes to mind is, of course, you can play around with the material if that's something you want to do. And the second, probably easiest thing that you can play around with is the Displace Modifier. And in particular, you should definitely try out the different types of noise that you can apply to this displacement, right? You can play around with the noise scale and the intensity, right? It's going to give you different results. Maybe play around with the way that the empty is going around this circle path, right? Maybe rotating the empty as it is rotating around this circle path. And of course, looking into the animation of the bobbing up and down, maybe it could be going side to side and so on. And if you have any questions, make sure to ask them in the comments. I'll be happy to answer. Next, check out this tutorial right here, where I go over the code of another seamless animation loop generated with a Python script. Thanks for watching.